to this new video. In this, we will cover the channels on which 2.4 gigahertz APs and 5 gigahertz AP can work, all the channels which are allowed in the frequency band of 2.4 and 5 gigahertz. We'll start with 2.4 gigahertz. We've already discussed that organizations like FCC or ETSI, they regulate the wireless transmissions in a country. FCC for US, ETSI for Europe region, right? They tell us which frequency to pass traffic on, or in a 2.4 gigahertz band, which part of frequency is allowed for us to pass traffic. Now, in 2.4 gigahertz spectrum, the starting frequency is 2.401 gigahertz. Okay, each channel in 2.4 gigahertz has a channel width of 22 megahertz. This is the channel width. So we'll start making the channels now. The first channel starts from 2.401 and goes to 2.423 because the width is 22 megahertz. Second channel is 2.406, that is 5 megahertz added. Goes all the way to 2.428. Then again 5 megahertz added all the way to 2.433. Then 5 megahertz added all the way to 2.438. Then again 5 megahertz added, starts from 2.421, goes to 2.443. Again 5 megahertz added, 2.426 goes to 2.448. Okay, again let's add 5. 2.431 goes all the way to 2.453. 2.436 all the way to 2.458, right? Let's name the channels or number the channels first. Channel number 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, and this is 8 for now, right? Again add 5, 2.441, 2.463, 2.448, 2.468. Sorry, this is not 2.48. This is 2.46 because we have to add 5 megahertz here. Yes. Okay. So the next one is 2.451, 2.473. To name the channels, this is 9, this is 10, and the next one is number 11. Okay, so if we take a look at this, we see that we have created 11 channels in 2.4 gigahertz spectrum. And we also know that channel number 1 and channel number 2, there is a lot of frequency overlap. 2.401 to 2.423 and then 2.406 to 2.428, channel number 2, they have significant amount of frequency overlap. However, if you see channel number 1 and 6, the channel number 1 start frequency is 2.401, ending frequency is 2.423. Whereas in channel number 6, the starting frequency is 2.426 and ending frequency is 2.448. There is no overlap of frequency, right? The starting frequency of 6 is 2.426 and the ending frequency of 1 is 2.423. So there is no frequency overlap between 1 and 6. Similarly, if we check the frequency of 6 and 11, we see again similar behavior. The ending frequency of channel number 6 is 2.448 and the starting frequency of channel number 11 is 2.451 gigahertz, which means there is no overlap of frequency between 6 and 11 as well. That is why we say that channel number 1, 6, and 11 are non-overlapping channels in 2.4 gigahertz spectrum. That is the reason why we say this. Now, also keeping in mind that the starting frequency of 2.401 is 2 of 2.4 gigahertz band is 2.401 and the ending frequency of the entire band is 2.473, which simply means 2.473 minus 2.401 gigahertz gives us 72 megahertz of channel width to send traffic. This is for United States because in United States we have only 11 channels allowed. In Europe, we have in US we have channel number 1 to 11. In Europe we have channel number 1 to 14. So if you keep adding next one becomes 2.456 to 2.478. We can go on to channel number 14 as well, but we'll stick to channel number 11 for now. 11 for now. And this for Europe, of course, the width slightly becomes more, but generally in most countries we have channel number 1 to 11 which are allowed, and hence we only get 72 megahertz of channel space to send traffic or bandwidth to send traffic. This is really, really less. And considering on top of this, we have baby monitors, cordless phones, microwave ovens, Bluetooth devices all function in the 2.4 gigahertz spectrum, makes it almost impossible for us to have a clean transmission of radio signals, right? Now that is the problem with 2.4. Now when we jump to 5 gigahertz, this was 2.4. When we jump to 5 gigahertz, we see a different picture altogether. In 5 gigahertz, we got something called an unlicensed national information infrastructure band, which is called a uni band. Okay. A uni band is given to us to send more traffic. Of course, we know that 2.4 was very congested. We wanted to get more bandwidth to send traffic on 5 gigahertz, and we got three uni bands from the government to send traffic. That is Uni 1, Uni 2, and Uni 3. These three bands we got to send traffic onto the 5 gigahertz spectrum. Uni 1 is also known as the lower band. Uni 2 is known as the middle band. And Uni 3 is known as the upper band. Okay. Now, Uni 1, anyway, before we get to that, when we got these three bands, we were a little more greedy. We wanted some more bandwidth to send traffic, and hence the government came up with a solution. They gave us a Uni 2 extended band for us. Okay. So we got four bands, also known as the extended band, to send traffic. Okay. Now, this Uni-1 band, let me just correct that again, supports frequency range of 5.15 to 5.25 gigahertz, which is a 100 megahertz wideband, right? So 5.25 gigahertz minus 5.15 gigahertz gives us 100 megahertz of band. Okay. And this entire band has four channels. The Uni 2 band covers 5.25 to 5.35 gigahertz of space, also giving us 100 megahertz of band, also has four channels. Now, Uni 3 band covers 5.725 to 5.825 gigahertz, again giving us 100 megahertz of space, and again has four channels. Now the new band, that is Uni 2 extended, covers 5.470 to 5.725, giving us 255 megahertz of band, and this has 11 channels in it. By the way, if you add these frequencies which are available to us, the total becomes 555 megahertz of frequency band to send traffic, and this has 4 plus 4 plus 4 plus 11, 23 channels in total, and all of them are non-overlapping in 5 gigahertz. Okay, so in 2.4 gigahertz we have 72 megahertz of traffic with three non-overlapping channels. In 5 gigahertz we have 555 megahertz of traffic and 23. By the way, now it's 24. We have another channel that got added. So we have approximately 24 non-overlapping channels. Okay, that is why 5 gigahertz is extremely spacious. The spectrum available for us to send data is almost 8 times of what is available in 2.4, and also it is free from all the disturbances like Bluetooth, microwave, and baby monitors, etc. That is why we always prefer 5 gigahertz communication. We always prefer clients or networks to be deployed on 5 gigahertz now and not on 2.4 gigahertz. This is a clear example of why we do that. Keep this in mind. You need not remember the maths, but you need to know why we say that 2.4 gigahertz is not good enough anymore. We need to go on 5 gigahertz now. Okay, cool. So we will continue in the next video. Thank you.